A resistor is a passive two-terminal electrical component that limits the current flowing in electrical or electronic circuits. Resistors are available in different sizes. Its size is directly proportional to its power rating. The power rating is the maximum amount of power that a resistor can dissipate without being damaged by excessive heat buildup. The larger the surface area covered by a resistor, the more power it can dissipate. Types of resistors. There are actually two types of resistors: fixed and variable. Fixed resistors are designed to set the right conditions in a circuit. Their values should never be changed to adjust the circuit, since those were determined during the design phase. It can have a carbon composition or chip and wire wound type. It can also be made with a mixture of finely ground carbon or be very small in size and for high power rating. Types of resistor materials. Below are different types of resistor materials, their pros and cons, and their uses. 1. Carbon film resistors are made up of a pure carbon film enclosed in an insulating cylindrical core, cut in a spiral to increase the resistive path. It is more accurate than carbon composite. However, in applications that require high pulse stability, special carbon film resistors are used. 2. Metal film resistors are produced with tantalum nitride, but more often, they are made using nichrome. A combination of ceramic and metal is used as the resistive material. It has better stability, temperature coefficient, and tolerance than carbon films. Typical tolerances are between 0.5% and 2% with a temperature coefficient between 50 and 100 ppm K. Stability is lower than Wirewound, but its high-frequency properties are better. 3. Wirewound resistors are created using a winding resistance wire that has a spiral non-conductive core. The resistance wire is made up of nickel chromium and the core is ceramic or fiberglass which has a coating protected with vitreous enamel. It is not suitable for applications higher than 50 kHz since the spiral winding has capacitive and inductive effects. It is best used for high precision or for high power applications. 4. Precision resistors have a thin bulk metal foil that is cemented on a ceramic substrate. It is the most accurate and stable type, and it features a very low temperature coefficient of resistance that is used for applications with high precision requirements. 5. Metal oxide film resistors. The resistive material is usually a metal oxide such as tin oxide. It is useful in applications requiring higher endurance because it has a higher operating temperature that makes it more reliable and stable. 6. Carbon composite resistors are made up of a mixture of fine carbon particles and a non-conductive ceramic material pressed in a cylindrical shape and baked. The resistance value depends on the dimensions of the body and the ratio between carbon and ceramic material. The more carbon you add, the lower the resistance. Carbon composition resistors are remarkably reliable but have poor accuracy with a maximum tolerance of around 5%. How do resistors work? Wiring a resistor in a circuit will reduce the current by a precise amount. If you look at resistors from the outside, they most likely look the same. However, if you break it open, you'll see an insulating ceramic rod running through the middle with copper wire wrapped around the outside. Resistance depends on those copper turns. The thinner the copper, the higher the resistance, since it's harder for the electrons to pass through it. As we've found out, it's easier for the electrons to flow in some conductor materials than insulators. Resistor color coding. For a 4-band color-coded resistor, the first and second band represent the first and second significant digit, while the third band represents the multiplier, and the fourth band represents the tolerance. For a 5-band color-coded resistor, high-precision resistor, the first, second and third band represent the first, second and third significant digit, while the fourth band is the multiplier and the fifth band is the tolerance. SMD resistors. SMD means surface-mounted device. It is used to create surface mount technology. SMDs have small leads or pins that are soldered to pads on the surface of the board, instead of wire leads that go through the PCB. This eliminates the need for holes in the board and lets both sides of the board be more fully used. Since SMDs are too small, there is no room for traditional color band code to be printed on them. For this reason, new SMD codes were developed. Resistor power rating. Every time a current passes through a resistor due to the presence of a voltage across, electrical energy is lost in the form of heat. The greater the current flow, the hotter the resistor will be. A resistor can be functional at any combination of voltage and current as long as it does not exceed the power rating that a resistor can convert into heat or absorb without any damage. Resistor power rating is defined as the amount of heat a resistor can handle without sacrificing its performance in no definite time. In Ohm's law, when a current flows through a resistance, a voltage is dropped across it, producing a product that relates to power. In other words, if resistance is subjected to a voltage, or if it conducts a current, then it will always consume electrical power. Given this, we can say that these three quantities, power, voltage and current, are in a power triangle. Using the resistor power triangle is the best way to calculate the power dissipated in a resistor if we know the values of the voltage and current across it. Additionally, Ohm's law allows us to calculate the power dissipation given the resistance value of the resistor. We can obtain two alternative variations of the above expression for the resistor power if we know the values of at least two among the three: voltage, current, and resistance. Thank you for watching. Subscribe for more electrical videos in future.